Well, hi, good morning. Thanks so much for coming and joining me here in my shop on today. It's February 19th, and what I'm doing today is I'm just going to be examining this radio and sizing it up for eventual repair. I don't think I'm going to be doing any work on it, although I may operate it. I don't know yet. So this is a pretty old radio, and it's in really good shape. I'm going to guess this radio is from 1935, somewhere around there. I'm not exactly sure just yet. This is a Canadian-built radio built by a Canadian company called Rogers. You can kind of see where it says Rogers down here. These dials look unbelievably new. They look unbelievable, in fact. The dial backing here. That's curious. How can a radio make it all the way from 1935 to here and have these cards look that way? I suspect they've been replaced. They look a little too new. Look, there's a knob on the side. It's kind of an unusual thing. Not sure what's going on with that. Something feels like it's sliding inside. Like it's not in place. This is tuning. Well, it's a gear-driven knob. Broadcast band only. This is going to be on, off, and volume. Speaker, of course, is right in the middle. Look at the woodwork on here. So I actually have a radio very similar to this, another Rogers radio, which I made an attempt at repairing quite a few years ago, and I actually abandoned the repair because despite the small size, there's a lot in this radio. First of all, it weighs a ton. This is really heavy. Way heavier than you would imagine looking at it. So we have more cabinet work. Is that actually inlay? Well, there's something there. I don't know if that's a wooden inlay. It's fantastic looking. Let's take a peek in the back. Yeah, she's jam-packed. It's full of Rogers tubes. Rogers tubes from back in this era in the 1930s, I believe, maybe very, very late 1920s. These tubes were all coated. This was the selling feature of the Rogers tube. They had a coating. Coating's on the outside, and the coating is grounded, should be grounded. And I think it's done with these clips here. As you can see, the coating is coming all the way down over top of the bottom of the tube, and it's meeting up with these clips. And I'm not sure how that's done. I'm pretty sure there's also a pin, primarily a pin that's dedicated to attaching to this conductive material they've sprayed on here. Usually you can see the pin connection protruding just down here. I don't see any offhand. Now someone's been fancying these up. Someone's drawn a star. It says new, open, 7, new, no, this is a month, April 7th, 1937. Okay, this one also says new, April 37. Huh, never seen that done before. Tested, okay, April 6th, 1937. And the last one, something or other okay, something 630, that's got to be 37 also. It's also stamped here. These are unusual. These are stamped with the retailer, Eaton's music department, I believe is what it says there. Eaton's music department. And then right at the bottom you can see Rogers, the brand of the tube. So it looks like 41S written there. It looks like 6B something written there. A7S written there. There's some more stuff written on here. 6B7. Yeah, that's what that could be. That could be 6B7. And 88. 88. This looks like 1955. Maybe that's 35. 1934-35. It has written on it. That could be the age of the radio itself. It's written 80 over here. This is the rectifier tube, a number 80. Notice it doesn't really match at all, these Rogers tubes. It's a Westinghouse 6A7. Yeah, you know what, the 6 is covered here. 6A7. S must stand for shielded. Jam-packed. Great big transformer. Let's take a look at the power cord here. So the outer covering is giving up the ghost down in this area, but the internal insulation looks just fine. And the wires still got flexibility in it. Let's take a look at this. Do we dare turn this radio on? Now generally the instructions are no. You should never turn on a radio like this without doing some examination, but okay, so this is done fine. What I'm looking for are any loose strands or any chance of a short occurring, and because of the style of the plug, they've moved the connections way far away from each other. Well, these are tight. I'm sure that's not the original plug. Not polarized, of course. Great big transformer in here, so probably this only goes to the prime area of that transformer. Has a base cover, metal base cover, so this whole thing is a contained can, if you like. Well, why wouldn't we try this? Try this out. Why not give it a whirl? Okay, let's give it a whirl. Let's give it a whirl. What about the antenna? No, wait a minute, another thing. The antenna. Wow, what's this? Well, okay, so up in the back there, I can see a wax capacitor. I see a big coil up here, probably an antenna coil. This is probably the incoming antenna lead. I mean, what else could it be? There's no terminals on here. And of course the back of the radio is long gone. Most of these old radios, the back is missing. This one looks like it never had a back. How would you even attach a back to it? Is it possible they sold radios with no back cover? Anything's possible. Well, I think really for this particular radio, the next sensible move is to plug it in and see what happens. Now, I've got safe ways of doing this, so I'm not too concerned that something terrible will happen. The worst thing is you can have a short in the power transformer. And if you just plug it in and don't really know it, it might not take too long before whatever's left of that power transformer leaves. So I'm going to use my dim bulbs here, these two bulbs. We're going to make it so just one bulb is in. Whoops, just this bulb here. Switch is off, so we should expect nothing to happen. You can watch this meter here jump if you want. There we go. Okay, so nothing's happening now. What would happen? There's no light on this to come on. But there's no power being drawn. I know that because the dim bulb is switched in and this is showing full voltage. Not an accurate meter in case you can read the scale on that, which I doubt you can. Okay, so we're going to power it off. We're going to turn the radio on. This time's a little more serious. So we're watching this light bulb. The idea here is if there's a problem in the radio, this light's going to come on full blast and stay that way. There's a good chance it's going to come on pretty bright anyway. what we're looking for is, as soon as it comes on and it's bright, it begins to dim a bit. That's a very good sign. Let's see what happens. Okay, it may take a while. Now, it's not obvious to you in the camera at all. I see this totally different with my eyes. It's dimming down. Okay, another indication is the voltage here. That's being supplied to the radio. It should be going up. It is 59, very low. A lot of it is dropping on that bulb, which you can't see anymore. So this is indicating there's nothing really serious going on with the radio. No short circuits as such. Never going to operate with 61 volts. I'm going to screw in another light bulb that's going to raise the supply voltage to the radio. I don't want to get a shock doing it. There we go. 98, 95, 94. That should be enough. Make something happen. What do we hear? I hear a hum. So we have a nice hum coming out of the speaker. Turn it up a bit. Oh my gosh, look at this. This radio works. So these are typical interference sounds you hear in my shop all the time. There's no antenna, so with a short piece of wire, the radio is likely to pick up the local interference signals, probably coming from my computer screens in here in the shop. Capacitively coupling the signals that are in me. I'm an antenna of a sort. Everything is an antenna, and I'm coupling it capacitively to the antenna. Just more noise. That's, there's some stations this is tuned. You can see that this is tuned. Where is it tuned? Just above 600 kilohertz. Chances of picking something up are just about nil. No antenna. We're not even on full voltage here. We're at 95 volts. So that's quite low. Enough to make it work, obviously, but that's amazing, eh? I think this is all original, and I'd be a bad boy to go in here and do stuff to it if it's all original. Let's stick a and it's working. Let's put an antenna on it. I'm gonna have to stop for a moment and go and do some antenna switching. I'm keeping the radio operating with the dim bulbs in case something happens. Something serious happens, those bulbs will go quite bright and I'll know immediately. And what I've got here is a lead to an outdoor antenna. Let's put it around like this. So even just getting it close. Turn it down. Now this is a terrible AM antenna, but it's what I got. We'll start with this. Make any difference? Oh yeah. I'm trying to decide if they're talking about sports or not. I think it is sports. So we're dialed in just below 600. The station, the sports station, is 590, so the dial's accurate. Sound is a little muffled. Now, there's a French station up around here, which I can sometimes pick up. There it is. Right where it should be. Wow. Okay, let's do a little more experimenting here. First of all, I want to check something. Check the safety of this radio. Now, it does have a big transformer, so I shouldn't be too concerned, but I'm going to unplug it from here. This is a this leads to an isolation transformer. I'm going to plug it right into the wall. Feel pretty good about that. There's a bit of a hum coming from this radio for sure. It just disappeared when I unplugged it. So let me plug it in down here. Okay, and that's a regular outlet, an unpolarized plug put in essentially at random. What I want to find out is there any AC on the chassis here before I get too involved. And find out some other way. I had to plug it in the wall to get rid of the isolation transformer. Now I can hear the hum quite distinctly coming from it. Is that surprising? On a radio this old, apparently full of original parts, it's surprising the hum isn't just screaming out of it and overwhelming. So I'm going to put one lead of my voltmeter onto a ground point. This is basically the third wire ground point, if you like, and touch the chassis. 19 volts. Okay, now we're going to reverse the plug here. Repeat the test. What do we get? We get the other half, but not quite. Those two numbers, 19 and 74, they add to 93, but we're actually feeding it with right out of an outlet at 115, 117 volts, whatever it is today. So this tells me there's no direct connection between the power line and the chassis, as there shouldn't be. And what's happening is there's some kind of capacitive connection, probably the transformer itself. Its windings have a capacitive connection to the metal can, if you like. That's probably what's happening. If I took a low impedance meter and tried to read this voltage, I might not see it. If I stuck a ground on here, it would be grounded away. So that tells me I shouldn't be too afraid of this next stage. Next step is back on the antenna, ground this. Look away. This might just improve the efficiency of the antenna. So this is probably 740 here. Wow, this radio is working really well, actually. Or visit crownwithacrown.com. Crown. Protect, maintain, save. So that chirpy sound you can hear is interference, caused by interference in my shop here.
Thank you. But even though you slept, you think you're okay to drive? If you drink a lot the night before, you could still be intoxicated. Only time, not a cold shower, a hot coffee, or a big meal can lower your blood alcohol concentration.
Well, let's try another antenna with this radio. I'm going to bring in a loop antenna, which should provide a better signal. See what this radio is really able to do here. I have to go fetch my antenna. Well, that hum is really quite distinct, independent of the volume. Almost certainly the power supply filtering is weak in the radio. So I'm going to try this antenna here. It's a large loop antenna, tuned loop antenna. There's a tuning capacitor back here. These are the leads from it. I have to hook up both leads to get a loop to get the full effect here. The loop antenna can produce a lower level of signal, but what you get is much better signal to noise ratio with it. It doesn't pick up noise as well as a long piece of wire. That's the idea. So I'm going to ground this other terminal here. I guess I have the volume turned right down. There's no ground terminal as such. I guess maybe they were not anticipating a loop antenna. That's a little odd. I think they were very common back at this time. Let me just put a clamp here. Okay, so loop antenna connected. Now the loop antenna has to be tuned. It's picking up next to nothing here. Pretty sure it's tuned way in the wrong place. Okay, I shall tune the loop antenna.
I will go with, and there's a direct correlation here, Mitch Marner in figure skating. Okay. Pairs or no? Just a single. The men, I want to say the men's short program. Okay. I think his edge work is very transferable to what they do in figure skating. And you can make that argument for a lot of guys, but I think that
the best antenna.
Edge work is the best on the Toronto Maple Leafs. Interesting. And I think it would be a great transition for him, and I think he would.
The noise interference is much less now,
but he certainly has the basis for it. Okay, Jeff Skinner grew up a figure skater too, making all that bank with his incredible edge work. By the way, it's called a hammer throw ball, and it weighs 16 pounds. That's it. It only weighs 16 pounds. I thought it was more.
So I had this tuned.
But think about it. Pick up a 15-pound weight at the gym and try to throw it across the room. I'll stick with my 6.5.
Keep turning the volume down.
That's not really easy right now. Leafs and Blues tonight. Sportsnet 590 The Fan. Leafs Nation pregame gets going at 6 with Gord Stellick.
This is a directional antenna too. So
Brent Gunning, the host of Leafs Nation pre. And Gunn, good morning. Listening to our topic. Do you have an athlete? Do you want to save it to the end of the conversation, or an athlete popped into your head?
No, listen to that radio.
Toronto teams that could compete in the Olympics in another sport.
Fantastic.
Yeah, I'll jump in right now. I feel like half of the Toronto Raptors.
Now, as I tune the radio, I leave the tuned point of the antenna. So I got to go back and retune it. Station right there. Oh.
Now, yesterday, over 100 people were arrested, including 4 organizers of the convoy. Police also had 21 vehicles towed. All
Although the interactions remain mostly peaceful, Ottawa police tweeted out that yesterday some officers were assaulted, their weapons attempted to be stolen, and even one person threw a bicycle at the feet of a police horse, making it fall to the ground. Now, we'll continue to monitor this situation as it unfolds. We'll have eyes and ears in Ottawa later this afternoon, but we're also keeping an eye on the House of Commons, the House.
Yeah. So I've gone from 680, that was 680, we're listening to 740, and now I have to retune that antenna again.
Buckle in, everyone. It's time to get this show on the road.
Okay, let's see if we can get that French station, 860. So it's out of the range of the antenna tuning. Let me tune the antenna again.
And the best part is it's odorless, greaseless, and so you can use it every day, even under your best clothes. The number to call.
So I think this is 820, a comedy channel.
212-4181. And just so you know, Dr. Janet has arranged a very special offer. This is only available to your listeners. So when you call, be sure to mention this program and you'll get a risk-free trial of Dr. Janet's extra strength glucosamine pain relief cream. Again, this is only available to your listeners and only if you call this toll-free number. It's 1-800-212-4181. Plus, if you call in the next 10 minutes, you'll also receive an extra free supply with
station
your order
identifier here
to keep for yourself or share with a loved one or a friend. So, folks, this is a really great offer. The number to call is 1-800-212-4181. And remember, you have absolutely nothing to lose here because Dr. Janet's extra strength glucose.
For all I know, this could go on for half an hour. It could be one of those things. The French station should be just up here. Okay, they're playing music right now, which I cannot tolerate on my videos for copyright reasons. What? Now, normally I can't pick up anything above this. Let's give it a try. Using the loop antenna gives me an advantage. I'm going to tune it just to the noise here. Okay. Tune again. Oh, I gotta keep my hands away from it. Tune again. Very unlikely to pick anything up here. I'd be floored, in fact. There's a station there. Let's see if I can rotate the antenna so I get a better aim on it. So the best thing I can do with a loop antenna is aim it so the null of the antenna is pointing at a noise source to get rid of the noise source, which is what I did here. And that's letting the station come through. Pretty impressive. This is really impressive stuff here. A lot of it has to do with the antenna, but another station. Okay, that's tuning out in the antenna.
Remember, they called you're sick, and they called an aggravation to their own father by telling you that he's very.
Wow, this is great, oh man. This would be one I'd be afraid to work on for fear it comes out worse than when I started. That's amazing. I'm impressed. We're way up high now, 1400. Let me just tune the antenna again. What's going on there? This isn't even connected to anything. Ooh. Something a little loose in here. Wow. Okay, let's carry on. I'm just interested to see now what he can pick up. There's some low power local AM stations in and around Toronto. Kilowatt, 5 kilowatts, stuff like that. Up at the very high end of the band, which I never pick up here. Not like this, not in my shop here. I don't think they're going to show. Yeah. Well, that's really, really surprising. Let's see, what would be reasonable options here with a radio like this? Let me just turn it off. So it would be reasonable to try to knock that hum out. Doing that probably involves, well, let's see, can we see what kind of speaker's in there? Yes, I can see it. There's a field coil type speaker in there. Generally that comes with small capacitors associated with the field coil in the power supply filter. 8 or 10 microfarads as opposed to big ones, because the coil does an awful lot of the filtering. So it'd be easy probably to get at those capacitors, probably just inside here, and replace them. That would eliminate the hum. But, you know, wow, it's a working radio even as it sits here. And it's got to be the case, because I can see one, what I assume is an original wax capacitor. There's a bunch of them inside here. It is possible this thing got restored somewhere early in its life. I doubt it very much. These Rogers tubes are fairly rare. I have a few. So it's a good thing that they all are operating, that's for sure. Anytime you do anything to one of these old radios, there's a risk that you're going to inadvertently damage something, or inadvertently make a situation go south instead of north. I'm in Canada, north is better. Well, we could, without too much risk, pull it out and take a look inside and see what's going on. We could then size up whether I want to do the filter capacitors or anything more than that. I mean, you could go ahead and do all the capacitors. My experience with these radios is they are jam-packed inside here. Well, you know, I think it's a low risk to take it out and have a look at it. Let's do that. We'll do this. We got a couple of knobs on the front. You know, these really do not look original. I mean, how could it possibly be? Okay, so There's tape around here to try to make the knob hold on better. These are not original. For sure there isn't making sure there isn't a screw. No, I think it's coming off. Oh yeah, it's got some tape on it too. I'm pretty sure these are original. Radio must be. Oh, this one here has. Oh, this is a toughie. Hard to get a grip on it. There. Oh, well, it's mounted right into the cabinet. That's right, I remember now. So they do have a radio very similar to this. Doesn't look identical, but very similar. It also has this up on the side. What is this? What was this for? It just feels like the whole thing is moving. Maybe this was tone control. Maybe it was muffled because the tone was turned low, and I just didn't realize it. It'd be very, very stiff wires in here. So pulling out the chassis with this piece sitting here, is there a chance I need to take this nut off and push this thing through? Let's take a closer look in here and see what we can see. Of those wires. Wow, okay, so they're taped. Something's gone on up in there. Seems to be some amount of wire. Looks like you could pull the chassis out some distance. There you can see that capacitor more clearly now. Does the speaker come or does it stay in the cabinet? It looks like the speaker stays in the cabinet. That's another problem. Hard to say for sure. Okay, so I can move the cabinet a little bit and see what happens. Look at it. It's like a row of soldiers here blocking your way. Or what? I guess today in Canada that would be policemen. A row of policemen. Okay, let's take a look underneath here. Let's see what's under. Oh, it's so heavy. Holy smokes! It's just so much heavier than it looks. 1, 2, 3, 4. They all look the same. We'll take them out. Take out the lower ones first because the radio can hang from the upper ones. The radio's in pretty clean condition too, so far anyway. It's not all covered in dust. Okay, the last 2 screws I can't. I mean, this is a massively heavy chassis here. Just going to hang it over the edge of my bench. This screw was loose. One was also loose. I'm sure if I brought my version of this radio in here, we'd see that these plates are a mess. Okay, any reason why we can't start pulling it out? So usually I like to get a grip on the transformer because that's where all the weight is, but it's a little tough with this radio. I'll just shuffle it out a little bit. Apparently that's easier said than done. Wow. It could just be its weight. Just keeping it in there. Ay, ay, ay. Okay, let's get gravity working for us here and see what happens. Famous last words. There it comes. Okay, we need to take a closer look in here again. Wires, some wires there. Looks like we can back this out from there. Now what's going on with the speaker? Speaker stay behind? I can't tell for sure. I think it's staying behind. Okay, let me look. Nope, speaker's coming with it. Everything's coming out but this piece up at the top right, top left. Further, I will have to. There's a big rheostat or something like that. We're going to have to take this out. Let's see if I can get it with these. Yeah, not tight. That's why it was pivoting when I was turning the knob. The whole control was turning. Whatever this control is. Only one band on the radio. There we go. Okay, there. That's it. The radio can come out from the cabin for sure. Okay, let's take a good look at the cabinet here. Well, nothing too special in there. Big number 5 stamped into it. It's number 5. Seems perfectly solid. Boy, this cabinet is in great shape, really is. Again, you know, have come all the way from 1930, whatever it was, whatever it is. 1934, 35. Okay, I'll take a look at the what more we can see in the radio now. There. These clips, to me, I mean, they're clipping onto what is really a plastic base, but it's got paint on it, but you don't rely on this to make a contact. It could be there was a different set of tubes in here. I don't know about that. Where a metal shield was required, slid over top of the tubes. So I just wonder if this is an upgraded radio, upgraded to these tubes, and then all these dates are written on here, and the Eaton's company. Like if this was made in the Rogers factory, it wouldn't say Eaton's on it because it would just say Rogers. So what's happened is Rogers is selling its tubes through Eaton's. Eaton's was a big department store, a very big deal in Canada. Eaton's department store. That's got to be what's happened. They've taken their radio and had it upgraded at some point to the new tubes, the new Rogers tubes. Hey, no need for these metal shields anymore. That's got to be the story on this. Okay, so see shielding. Oh my, a 3-part capacitor. Wow, this explains why there's so many darn tubes in this radio. How many tubes are there? 1, 2, 3. Well, 4 signal tubes and 1 rectifier tube. It's actually not that many. They're just all lined up at the back. Why would they be at the back? Possibly for cooling. You get much better cooling at the back. Maybe easy access. Change the tubes. They're all lined up right at the back. Just reach in. And Rogers was in the tube selling business. They managed to sell a set of tubes. Yes, through Eaton's. Eaton's got a piece of the action. The tube action. Well, this has obviously been done by somebody recently. Recently being within the last 40 years. Something like that. What happened to the original wire? Probably the insulation cracked, and whoever owned this at that time thought, ooh, that's a terrible piece of wire. Put this piece on. 3-section capacitor. There's the trimmer slugs. So this is one hot little radio. 3 sections means it's got 2 RF tuned stages rather than 1, which is typical in a small radio, just 1. You have a 2-section capacitor, one to run the local oscillator and the other one just tuning the very front, often tuning right against the, could be tuning right against the antenna if there was a loop antenna here, but there isn't. And there's the capacitor. Now, is that a replacement or is that an original? Does it say Eaton on it? No, can't. No, that's certainly not Eaton at all. It's some number. Okay, and we take a look down at the speaker. This is the field coil, which is an important part of the filter in the radio, the filter which isn't working so well because we're hearing a hum. But this also doubles as the electromagnet to make the speaker operate. Back at this time, it was not really practical to make strong permanent magnets. They couldn't make them strong enough. Once you could make a strong enough magnet to put in here, these coils disappeared. And the big power transformer. Now there should be another transformer for the speaker. Must be underneath. Should be another transformer. Okay, well, next stage is to get this button. Oh, one more thing. Let me take a look at this. So there's some tape on there. Does not look like factory soldering. And this has been replaced. This is quite a control here. I have to put the camera down to turn this. I think this is a, well, I don't know. I was going to guess that this is a wire wound rheostat, but I don't know. Can't really tell for sure like that. Lots of wire on it. Let's just look at the front here. The speaker's a little chewed up in some funny spots. The speaker surround is chewed up. And that's something in the cabinet. Oops. Let's take a look again at the cabinet. So a chewed spot would match up, well, around this nail here. Actually, the chewed spot matches where these nails are. Okay, or maybe they, I don't know. Maybe, I don't know. And the cone. We have a chance to look at the cone. So the center doesn't have a dust protector, but because it's been behind this, it's been dust protected all this time. Very good, indeed. Okay, how do we get the plate off? How do we get the plate off? So when you got a big transformer like this, oh, there's a little bit of warmth in it too. Almost warming up. It's got this tube and this tube heating it. Let's just do this carefully. I don't want to. Okay, we don't want to. Screw there, screw there. What's inside? What secrets in a radio that works so well after all these years? Rogers built good radios, I guess. Yeah, that's the bottom line. Off it comes. Oh, it's full of new parts. It's full of new parts. To my surprise. Well, okay, that is a surprise. It's full of new capacitors here. Wow, somebody really did a job on this. This is similar to the radio I have in the sense that it has a central connecting board, I guess you could call it, right through here. A lot of the parts are mounted right on the board. These are all resistors here, very old resistors here. This one looks like it's been replaced. These are the two new filter capacitors, so I can't imagine why the set is humming. 22, I mean, they're not small. Yeah, I'm not seeing, negative here. And I gotta guess this is the negative. This is going down to the chassis. This one's going over here. The two positives are connected together here. Two positives connected together. I don't think that's correct. Usually you have the big inductor, the big field coil, and then you have a capacitor on either side of it. In the more newer radios, the capacitors get really big and the coil turns into a resistor. Maybe a 30 ohm resistor or something like that. And then that kind of filter you're depending on the capacitors to knock the hum out. So it's just kind of curious. It's definitely both positives tied together. The negative going somewhere else. And the radio hums. Look, he's left an original capacitor in here. What's he done? He's changed the easy ones? These aren't even easy. Probably before these went in, this was pretty jammed up with stuff. These look like lower voltage capacitors. This one looks replaced too because of the way the soldering's been done here. And my experience with these are really reliable. Here's another capacitor up here. You can't see it. So there's some kind of coil in a can here. I have to assume this is the output transformer for running the speaker. So I think the question would be, did the last guy accidentally do something here that is not quite right? So because the radio's humming, and it really shouldn't be humming, my experience with these guys with field coils is even if the filter capacitors get very weak, and they usually start out quite small, 10, something like that, you still get almost no hum. The coil is very, very effective. That's my experience. Whether it's valid or not, I don't know. It's just my anecdotal truths. Okay, let's get the schematic for this radio and check it out here. And I haven't even identified the actual model number yet. Let's see if we can do that. Is my camera going to focus here? Is it on autofocus? It is not. Canadian radio patents. Serial number. Type. Is that the model? Type. Rogers Majestic Corporation Limited, Toronto, Canada. And what would that number be? I can't get close with this camera here. So autofocus is not going to do it. So I will look myself with my oh so powerful eyes. I can't see. Four five 4511. Let's use the camera and get it. I'll fix the focus on the camera. Here, just bear with me a moment. Force the focus to be set for being really close. Yeah, it is fixed focus. Just do that. Should be able to get pretty close now. 4511. 4511. Oh, there it is there. Serial number 4511-1933. Is that the model then? Is that the model? There's nothing else on here, is there? Saying anything about a model number? Approved. The Hydroelectric Power Commission of Ontario. Well, I don't think there's any other identifier anywhere on this radio. Could have been, maybe there was a back once in the cabinet and the back is gone and something has gone with it. Well, I'm going to hunt around and see if I can find a schematic for this radio. Okay, I found a good copy of the schematic here. Let's just take a zoomed out look at it on Pacific TV, which is on the west coast of Canada and has a lot of schematics on Canadian radios. I also found this same thing on Radio Museum, but the quality of the image was very poor. This is much better. So we're not going to look at the radio itself right now. We're going to take a look at this power supply and see what's going on here. Let me zoom in on it. What's going on in terms of the capacitors. So here's the high voltage area. This might be one of them here. C looks like 11. Let's see, what they've done here is the center point of the center tap on this transformer is not put directly to the chassis but drops through a couple of resistors on the way. This is a way of generating negative voltages with respect to the chassis. I hope I got that right. You can see them written right here. -3 volts. That would look like 10.5, 105, I'm not sure. But these negative voltages then are useful for grid bias. For instance, if we just follow up here, we'll see it does go to a grid. So that's what's going on with that part. That means these capacitors are probably not connected directly to the chassis. Yeah, I saw one of them was. Well, let's see. Now sometimes they locate these capacitors, filter capacitors, in what would appear to be pretty strange places. You know what? None of them are marked in such a way you can recognize them easily. There's the field coil. Field coil goes to the chassis. Yeah, okay, this might go just a little into a gray zone in my own head, but let's see if we can spot them over here. Large capacitors. 5, 1, and 1. Tubular. Double dry electrolytic. 8. Here they are. I'm pretty sure these would be them. C11 and C12. Double dry electrolytic. C11, C12. Okay, let's see 11. C11. C12 right there. And you know what? They have the positive side tied together, just like they are in the radio. And the negative side, one goes to the chassis, like one of them does, and the other one's going to a point, probably this point. Okay, so I guess they're done correctly. If we consider just looking at all the different ground points here, see they put the cathodes right to the chassis, and then they use this relative negative voltage here to bias the grids. Are they doing that way up here too? Do they not use the, where's the detector? Where's the, here they are. Right here. So yes, and then it's fed back. Yeah, so this is the, going to go to a grid through the coil there. Grid, grid, screen, no. Okay, so I think in this tube what they're doing is they're using this grid as a plate right here. This is the oscillator circuit, the local oscillator circuit. Ground wire black, antenna wire green. Well, it's white in our radio. It is curious arrangement here. That's curious to me. Yeah, I'm going to study this a little more if need be. For now, all we were really interested in was, did something go wrong here? Why is this radio humming so much? And these are supposed to be 8, and in the radio they're 22. They're 3 times as big. Now, making an 8 microfarad capacitor was a bit of a big deal back in the day here, which is why these are only 8s, not 10s, 12s, or 15s, or whatever. They just get bigger and more expensive. Of course, the 22s that are in there are tiny compared to this. So, would putting big capacitors here cause the thing to hum? I can't imagine that. So the way this is filtering is just a little bit confusing to me. Yeah, this is a little bit confusing how this is shown. So, well, I think maybe this might be it for today. I'm going to study this schematic a little more. Still not sure if I'm going to do anything to this radio at all. Look up here, we have a hum coil. So the radio does expect hum to be present in this transformer, and for this hum coil to buck it. That's my understanding of what a hum coil is all about. So the field coil, they can't eliminate, it's in here. They can't eliminate all the hum that exists in this coil. how this works exactly. I will go quiet on that. Must be the amount of hum that's generated at this point is in opposition to the hum that's magnetically coupled from here up towards the voice coil. And then the two of them end up nulling each other out, so to speak. There's the tone control, by the way, down here. Tone control on the side of the cabinet. Model 4511. I wonder if the other radio I have is exactly the same model. Nothing too spectacular. Oh, nicely listed everything here. 41, a type 41 output tube. 6B7, type 88S. This doesn't show any shields or show any shield grips. We don't know. Would that be in the parts list? And somewhere where the just general parts are shown? Doesn't look like it. They probably wouldn't show a shield. Sometimes these things have every part on them because the manufacturer was selling the parts and wanted to help people identify what it is they wanted to buy. These are all capacitors. Wow. Yeah, I don't see anything here that's going to indicate whether there's a item. T, these are all transformers. Yes. Well, it's quite a radio. It really is quite a radio. Let's look at the tuning before we quit here. So here's the three gangs. So here you're tuning against this coil. Here you're tuning against this coil. Both ahead of the tube here. So we're not tuning down in here. Well, we are. We're tuning the local oscillator here, but that's not what I'm talking about. So I have two tuned stages prior to the grid on the first tube. Some aligning instructions written right on there. Well, why the hum? I think that's the mystery. Why the hum? Why the hum? It's always possible that an error was made in the work that was done. Some other error was made. That doesn't make a lot of sense. You'd think that once the filter is operating here properly, the field coil and the two very large capacitors, hum really shouldn't be present down in here. But often the voltage that's being applied here isn't filtered as well. Well, no, it's coming off this line. Everything's coming off this line. Why the hum? I wonder if these hum coils are adjustable in some way. I don't think they are. Just peeking at it, nothing obvious. I don't think they're adjustable at all. Okay, that's the mystery. Why the hum? What do you do about it? Well, you know what the hum could be. The hum could be coming from one of these tubes. And these have all got cathodes. Or would even a bad rectifier tube result in a hum? Maybe because the tube is weak. I'm just guessing here. Just talking off the top of my head. Maybe additional hum is in the field coil and it just can't be compensated with the hum coil. I don't know. It's a big guessing game. Great. Let's just go back and look at the radio here for a minute. Well, very surprising investigation. I thought this would be a dead dog full of old capacitors. Instead, she's alive and well, humming right along. What about this last capacitor that got missed or left? The guy who did this knew what he was doing, I'm pretty sure. Could be he left that because he knows it just isn't important at all. Seems a little odd. Well, he left this one up on the top here too. You know, that could be oversight. That's pretty easy to replace. Why wouldn't he do it? Yeah, oversight. Yeah, pretty hard to overlook that one. Kind of hard to overlook this one too. So, well, we can investigate that a little bit, figure out what those are, and could they introduce a hum. Yeah, lots of old resistors in here, could have gone off. So yeah, you know, this capacitor is going right to the chassis. Is it a good capacitor? What's it doing anyway? It's on the first tube. It's on the front tube. I don't know. Interesting. Well, thanks a lot for watching, and I've got to get ready now for a customer who's going to drop off actually the next project I'm really going to work on. I'm going to set this aside. I got an idea now what's in store for me with this, and we're going to attend to another radio, a nice console, beautiful console, and then maybe I'll get back to this one afterwards. I'll give me some time to think a bit about it. Do I really want to poke around? Well, I'm not. There's nothing original about the insides anymore. Just on that note, replacing capacitors and destroying the originality of a radio like this. What is remaining original is the circuit design. So if a few components got to go to keep the original circuit operating, you still have the circuit design functioning. That is being preserved even though you're doing this. In fact, to some degree you're preserving it more because it can be used and played and enjoyed. That's my thoughts on that. Okay, see you on the next video.